So now we have another question that's based on the composite body method. We did one, or I think one or two questions which are based on addition of bodies, and now we have a question that is based on subtraction. Now, what kind of subtraction? We have a larger body of radius a, from which another small body of mass of radius a by 2 is cut off, right? And which results in a figure like this. So what we have here is the yellow mass, which represents the remaining area, right? And this black region here represents the whole. I hope the visualization is clear to you from this. So you're able to see the black background because there is a hole here, which was not the case in this figure, right? Now that we have the remaining area, we will have to find out the center of mass of this remaining area. So we will use this terminology. The larger area will use the phrases M1, A1, X1 and Y1, and for the cutoff region we'll use M2, A2, X2 and Y2. Now another word comes into consideration here, which is what? Which is uniform distribution, right? Uniform distribution, something that we have discussed in detail while we were discussing the topic of addition of bodies in composite body method. Now the question doesn't use the word uniform distribution. Let us verify it one more time. A circular hole of radius, weight is cut off, circular disk of radius, the center of the remaining circular portion is yes. It is mentioning only about the shape of the figure, not about the uniform distribution. And we assume here, right? We assume here that the given mass is uniform in nature. And if the given mass is uniform in nature, we can safely say that both of them will have the same mass density. Sigma will be the same for the larger mass and for the cutoff mass. I hope that makes sense. Now, let us first consider the larger mass alone, which is the larger circle with a radius a. So, what is the center of mass of a circular sheet? We know that the center of mass of a circular sheet will overlap with this geometric center. Why? Because of the symmetry. In which case, for this circle here, Ax, y represents the center of mass of circular sheet. Now, this Ax, y, the point A having coordinates x, y is not equal to x1, y1 in the formula of center of mass. Why? Because Ax, y is the center of mass of the circular sheet, but x1, y1 is the coordinates of center of mass with respect to a what? With respect to a origin. And when we consider center of mass of circle 1, Ax, y, with respect to a origin, what we get is the coordinates of point A dash, which is a, 0, which represents x1, y1. Why? Because Ax, y is read with reference to a origin, which is measured with reference to a origin, giving the point x1, y1. Therefore, x1 is equal to 0. Sorry, x1 is equal to plus a and y1 is equal to 0. Let me just make sure that the visualization is clear. So, if you consider the point Ax, 0, right? This was in reference to the center of mass of the circle. Now we need to consider the center of mass of this circle with respect to origin. In which case, what we get here is x1. So what is x1? X1 would be the center of mass of this circle with respect to the origin O. And what is the measure of x1? The measure of x1 is OA. What is OA? OA is equal to the radius. What is the measure of radius? It is equal to A. Right? And therefore the coordinates of the center of mass with respect to this origin are A, 0. Now we will have to consider the second mass, which is the cutoff mass having the radius a by 2, which is a circular mass, say with the center bx comma y, with this radius r. And what is the given radius r here equal to? The radius r is given to us as a by 2. Now, what is the center of mass of this circle? We know that since the circle is a symmetric figure, the center of mass of the circle will overlap with the geometric center. Therefore, bx comma y will be equal to the radius of the circle comma 0, which is a by 2 comma 0. Now again, is bx comma y equal to x2 y2? No. Why? Because x comma y represents the center of mass of the circle, whereas x2 y2 represents the center of mass of the circle. What? With respect to origin. So now what will we have to do? We'll have to consider the origin here. So bx comma y is the center of mass of this circle, labeled with blue, whereas b dash represents x2 y2, which is the center of mass of the circle 2 with respect to origin, which will be equal to a plus a by 2, which is equal to 3a by 2. And since y bar is lying on the x-axis, y2 dash will be equal to 0, right? We'll go through another diagram so that things will become really clear to you. So we consider only the smaller circle here, the one which is cut off, and the center of mass of this circle is the point B, and the center of mass of this circle with respect to the origin is actually, let us say, is B dash, right? Is B dash. And what is the measure of this B dash now? What is the measure of this coordinate now? It is OB dash, right? It is x2 is equal to O. Okay, since I've used B dash, B, let us use only B. So x2 represents the distance of center of mass of B with respect to the origin O. So this distance OB represents x2. So x2 is equal to OB. How can we write OB as? Geometrically, OB should be equal to OA plus AB. OA plus AB. What is the measure of OA? OA is, hey, what is the measure of AB? AB is a by 2. So we have a plus a by 2, which gives us 3a by 2. And since the y coordinate being lying on the x-axis, the y coordinate will be equal to 0. Now, see, I would suggest you draw these two diagrams once, like this one and the one we discussed for the first figure. Draw this diagram one time, and draw it very detailed, where, say, draw the x-axis, y-axis, mark these using a pencil, draw it using a pencil for that matter, and then when you write it, the coordinates of the x1 alone, use a pen to highlight these 2 points, and then things will become really clear to you the next time you revise it. Okay, it should come in, the visualization should be very precise in your mind. Okay, so these are the only coordinates that should come into your mind once you see this picture one more time. Okay, I hope you get the crux of the message that I'm trying to convey. Okay, so now we've discovered the values of, now we find out the values of x1 and y1. We'll put out the figure one more time. So this point here represents the center of mass. This represents the center of mass of the first figure with respect to origin. And this point here represents the center of mass of the second figure with respect to origin. So both of these are with respect to origin, and therefore are x1, y1 and x2, y2, which is a comma 0 and 3a by 2 comma 0. Now comes the next question. What is sigma? Sigma is equal to mass by area. Why? Because sigma represents area density, which is mass per unit area. So what is the mass of the first figure? It is m1. What is the area of the first figure? a1. Similarly, we have sigma is equal to m2 by a2. We don't have sigma 1 and sigma 2. Why? Because this represents, we have assumed that this lambda here is uniform in nature. So we have sigma is equal to m1 by a1, sigma m2 by a2. Now what is m1 from here? M1 from here will be equal to sigma. So we can write that m1 from this expression is equal to sigma into pi a square. Let us assume that to be capital M. What is m2 from this expression? M2 is equal to sigma into pi a square by 4. What is, and how do you get a square by 4? Because a by 2 the whole square is a square by 4. 4 goes up to the numerator. What is pi a, sigma pi a square? Sigma pi a square is m1, which is equal to m. Therefore, m2 will be equal to sigma pi a square, replacing m here, m by 4. So we can take m1 is equal to m and m2 is equal to m by 4. Okay. Now from this part, let us remove all the other things and let us keep only x1, y1 and m1, m2. In which case we have x1 is equal to a, y1 is equal to 0, m1 is equal to m. x2 3a by 2, 0, m by 4. So if we have x1, y1, m1 and x2, y2, m2, what else can we find out? The x coordinate of center of mass, which is equal to x bar, will be equal to m1 x1 this time minus m2 x2. Why minus? Because the body is subtracted in the composite body method. And so will be the case with m1 minus m2. Substituting the values, x1 is a, x2 is 3a by 2, m1 is m, m2 is m by 4. So if we divide this complete equation by m by m is 1, m by m is 1, 1, 1. So what we have is a minus 3a by 4 to 8. 1 minus 1 by 4 is 3 by 4. My bad, there should not be m here, right? So what we get is 5a by 8 by 3 by 4, which is equal to 5a by 8 into 4 by 3, which gives us 5a by 6. Now, okay, let us just bring the question one more time. So we have the question here. So the centroid of the remaining circular portion with respect to O will be, oh, that's the right question, will be equal to 5 by 6 times A. Now, yes, we have found out the answer. But what do we understand from this? I mean, of course, the solution. But yes, what is the takeaway message from this? Let us spend some more time to understand that. So see, we have the figure and the center of mass represented here in the form of a table. Now, please make sure, this is a very kind request that you take down this as well. I know the solution is over, but you know, this additional thinking of the solution, you know, additional thoughts which I've put into the solution, that will help you in deepening your concepts, which will in turn help you in solving questions when asked in the form of assertion reasoning without numericals. Okay. So say the main circle, which is the larger one, has the center of mass x1 comma y1, which is a comma 0. Now we have a hole which represents the mass removed out of this, like this, right? The center of mass of that portion was 3a by 2 comma 0, and we found out the remaining portion x bar y bar will be 5a by 6. Now what does this mean when it comes to the analysis part? So let me just erase this out. Okay, all right, let us say this a, the value of a is equal to 12. Sorry, the value of a is equal to 6, which means we have a main circle with radius of 12 units. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. All right. So when we say the main circle center of mass a comma 0, it means it will have 6 comma 0 because a is equal to 6. So when we have the hole with center of radius, center of mass 3a by 2, it means what we have is 3, 6, 3, 18 by 2 is 9. So center of mass is at 9 comma 0. And therefore the center of mass 5a by 6 for the remaining figure will be equal to 5 into 6 is 6 by 6 by 1 at b will be at 5. So the earlier center mass of the figure was at 6 comma 0 when some mass was removed from the right end. Take down this thing. When the mass was removed from the right end, the center of mass of this remaining figure shifted towards the left of the first center of mass. 6 comma 0 was the first one. It shifted towards the left of it, gaining it to 5 comma 0. Okay, so that is the reason why we have discussed this. As I said, association reasoning, yes, but there are a couple of other questions coming up which will give you some, certain additional sense that will help you in additional sense out of the given question, for the matter even from the solution. Okay, right. So take down this thing with me, and then we'll move on to the next question.